Now in this part we will learn about the permanent pressure belts of the earth. Now the atmospheric pressure is not the same throughout the earth's surface. The variation in atmospheric pressure is mainly due to the unequal heating of earth's surface. So a pressure belt is a region on the earth which is dominated by either high or low pressure cells. There are three low pressure belts with alternate belts of high pressure. First we will learn the equatorial low pressure. So the equatorial region is located between 5° north and 5° south latitude, okay, both in northern as well as southern hemisphere. Now what happened, due to the vertical rays of the sun at the equator, the temperature here is high throughout the year. The heated air being light rises up towards the tropics, forming an area of low pressure. The equatorial low pressure belt extends from 5° north to 5° south latitudes, as we learned earlier. This belt is also called doldrums, which means that in this area there are no surface winds and calm conditions prevail in this belt. Okay, this belt is also known as intertropical convergence zone, or in short form we call it ITCZ, as the northeast trade and southeast trades meet here. So what happened is that in this area, due to temperature remains very high and humidity is very high, every day at 4 o'clock, okay, there is heavy rainfall. So this phenomena or this rain is called 4 o'clock rainfall, because this area is tropical area where they receive direct sun rays. Next is subtropical high pressure belt or horse latitude. So the subtropical high pressure belt is located between 30° to 35° north and south of the equator. In this area or in this region, the calm conditions prevail in absence of surface winds. That is why this belt is also known as horse latitude, and this is a zone of divergence. Now let's talk about the formation of this high pressure belt. This pressure belt has formed due to the earth's rotation. The hot moist air ascending over the equatorial low pressure belt is flung towards the poles. This moves horizontally at higher altitudes, and as the air cools down it becomes dense, heavy and starts to subside between 30° to 35° north and south of the equator. Now earlier we learned that this belt is also called horse latitude because that this area there is absence of surface wind. Now what happened, in the olden days the sailboats carrying cargo, passengers and horses used to get stalled in these subtropical high pressure belts due to the absence of surface wind. To lighten the boats, the horses used to be thrown overboard, hence the name horse latitude is used. Now earlier we learned that this zone is also called as divergence or the zone of divergence, because the descending air currents from the trades and the westerlies on the surface blow out of this belt towards the equatorial low and subpolar low pressure belts. Let's learn the next one, that is subtropical low pressure belt. So the subtropical low pressure belt is located between 60° to 70° north and south of the equator, as you can see in the diagram. It is located just below the poles and around the Arctic and Antarctic circles. It is also known as circum-low pressure belt. Now due to rotation, the equatorial air is thrown outwards and cools and subside at the horse latitude. This belt is characterized by cyclonic storms in winter. The subtropical low pressure belt is a zone of convergence of the cold polar easterlies and westerlies which blow over the warm currents to generate cyclonic weather. This subtropical low pressure area is best developed over the oceans where the temperature difference between winter and summer is small. The next one we will learn, that is polar high pressure belt. Now this belt is dynamically induced. Now that means that this belt we see that is around up to 70° north and south. That is how in this belt there is a presence of high pressure. Why? Because the extremely low temperature throughout the year cause the air above the frozen surface to become cool, dense and heavy, which then subsides. Another thing, that this region receives very low insolation, means incoming solar radiation, and remain cold throughout the year. That is the last one, that is polar high pressure belt. Then the another phenomena of this pressure belt is that they are shifting. So see the next topic. Our next topic is shifting of pressure belts. So we learned all the pressure belts, but these pressure belts are not static, because we know the temperature of the earth's surface control the pressure belt. So temperature or the distribution of temperature on the earth's surface is not even. So as the sun moves north towards the Tropic of Cancer during March to June, and the south towards the Tropic of Capricorn during December and September, December and September, these pressure belts also shift a little to the north and south along with the apparent movement of the sun. This phenomenon we call it the shifting of pressure belts. The amount of shift is more in the northern hemisphere than in the southern hemisphere. Why? Because as there is more land in the northern hemisphere and the average temperature is higher. Thus each pressure belt shifts 5° to 10° from its normal position. So these are all the overall significance of pressure belts on the earth's surface.